Hey, in this video, we want to talk about the OR principle, or the additive principle of counting. In part 1 of the video, we talked about the NOT principle, and you use that to find the complement. So you find the total number and you subtract out the complement of what you're looking for. In this part of the video, we want to focus on the additive principle, which is here. The number of ways that one or the other of two conditions could be satisfied is the number of ways one of them could be satisfied plus the number of ways the other could be satisfied minus the number of ways they could both be satisfied together. And really what's going on here, and it might be really obvious, is you add the two different things together. So the number of ways you can do one thing plus the number of ways you could do the other thing. But what you don't want to do is double count, and that means you have to subtract out the intersection. It says if they are disjoint, which means they don't have any outcomes in common, then you just add the two together because the intersection would be empty. Again, just like the NOT principle, I think you seeing what's going on here will make this a little bit easier. So let's start right off the bat with a problem. In the first problem, H, if we carry on with the problems that we did in part 1, if you draw a single card from a standard 52 card deck, in how many ways can you obtain a jack or a queen? So key word in this problem, once again, is OR. And OR means you add them together, whereas AND means you multiply. That's that fundamental counting principle. I often call it the multiplication principle. But OR means you'll add these two outcomes together, but you've got to make sure, you subtract any outcomes that are in common. Now what I've done, for folks that don't remember cards very well, I've listed all 52 cards over here on the right, and you'll notice we can highlight the jacks. Okay, so all of these, let me put my highlighter on, all of these values you see are jacks. How many jacks do we have in a deck of cards? Well, notice there's 4. So that's going to be 4, or we could call that the number of jacks. And again, since it says OR, we're going to add the number of queens. And the rule says we have to subtract out the intersection of jacks and queens. So one thing at a time. The number of jacks we've got highlighted. How about the number of queens? Let's highlight that in a different color. How about green? So if we highlight the queens here in green, notice once again there are 4 queens because there are 1 queen in each suit. So I'm going to add 4 for the number of queens, and we subtract out the intersection. Now, are there any jack queens? Well, there are not. So you can't have a number or one of your letters be the same thing. Like a 3 and a 4 card, it can't happen simultaneously. Now you could have a red queen or a black jack, but you can't have a jack queen. So the intersection here again is 0. We don't subtract out anything because there is no jack and a queen. So 4 plus 4 is 8. So the number of jacks and the number of queens is 8. And of course you could just see right here highlighted how many cards do we have highlighted. We have 8 cards highlighted. Now let's talk about question I down here. If you draw a single card, you keep going, from a standard 52 card deck, and how many ways can you obtain a card other than a jack or a queen? Now I threw this in there just to remind you of the complement. So do you want to count all the cards that are not jacks or queens? It would be easier to do the complement. So you take the number of cards, period, in a standard 52 deck, which would be 52, minus the number of not jack or queen. And we know both of those. So the number of cards in the standard deck is 52 minus the 8 that's a jack or queen that we've already found. And of course 52 subtract 8 is going to give us 44 cards. Now if you wanted to count the 44 cards that are not highlighted, you certainly could do that. But it's easier to find the complement and just subtract that from the total number of outcomes that you have. So next question, if you draw a single card again from a standard 52 card deck, in how many ways can you obtain a heart or a 10? So once again, a heart, how many hearts do we have? Now, you probably know in your head that we have 13 hearts. So look, we could highlight all of the hearts. You could count them and you see that there are 13 of them. If you know a standard deck of cards, that's something that you know very well. If a deck of cards is brand new to you, then you might benefit from having this over here and highlighted. Okay. Now also, we could highlight or a 10. So let's highlight the 10s. There we go. So all of those cards are highlighted. Now if I use the formula says whenever you have an or, now you definitely need the or. If it said and, you would have to multiply. So if it said of drawing a heart and a 10, okay, as two different cards. Now, as a single card, it would be something different. That would be like the intersection. But two separate cards, then you would multiply these together. But now if you say or, then you would calculate the number of hearts plus the number of 10s. But then remember you have to subtract out the intersection. So a 10 intersected with a heart. Okay. Number of hearts is how many, the green I have highlighted. We know that's 13. Plus the number of 10s. That's the blue that's highlighted, but keep in mind there's a 10 right there also that looks green, the green 1. But 1, 2, 3, 4 cards. But minus the intersection. And that guy right there in the middle, when I'm going to highlight a different color right here, there he is right there. That is the intersection. That is a 10 of hearts, and there's only one of those cards. So I need to subtract that value out. So that's 13 plus 4 minus 1. That's going to give me 16 cards. Again, 13 plus 4 is 17. 17 subtract 1 is 16. If you count these, you would see that 16. This is 13, and then 14, 15, 16. Again, we're sure not to count that 10 of hearts twice. All right, so I have two more problems, K and L, is associated with this table right here. It says the table categorizes 20 senators as to political party and gender. One member is chosen at random. So again, we're just pulling one member out. In how many ways can the chosen person be a man or a Democrat? Okay, so chosen person being a man or a Democrat. Now, if I use the formula, notice again the word or is key. So when you see or, you know you need this formula. So you need the number of men or man plus the number of Democrats. I'm going to abbreviate that. Minus the intersection of man intersected with Democrats. Okay, or Democrat men, right? So the number of men, if you'll notice the column here, it's got a column lined up. There are, as far as the men column goes, there's 8 Democrats, 3 Republican, but 11 total. So that's the number of men, which is 11, plus the number of Democrats. Now when I look at Democrats, I need to look at the row, and the total Democrats is 12. Excuse me, minus the intersection. Now the intersection of men and Democrats, we have that number, right? That is this number right here. A man and a Democrat, we need to subtract that out. Why? Because we counted it twice. We counted it when we did the total of 12 Democrats. We counted it when we did the total of 11 men. And we don't need to count it 2 different times. So 11 plus 12 is 23, and 23 subtract 8 is going to give us how many? So we get 15 as our final result. Now, how about you pause it and you try question L on your own and come back and see if we get the same results there. So what about a woman or a Democrat man? So here's the rule. So if you, or means we need to find the number of women. Or means add, so plus the number of Democrat men, okay, minus the intersection. So you're doing the intersection of women intersected with Democrat men. And that might give you a tickle, I don't know. So the number of women, first let's just look back at our chart, and we'll talk about what in the world's going on here. So the number of women total Down here is 9, right? So there's 9 women plus, let's change colors. How about the number of Democrat men? We looked that up just a minute ago. There are 8. Okay. And then we have to subtract out the intersection. So women and Democrat men, notice that's disjoint, right? There aren't any values that are both women and Democrat men. There's no place in our column for that. I tried to change that to red. There's no place in our column for women that are both women and Democrat men, so we're subtracting out nothing in that particular situation. So that final answer is 17. All right, so for example M, it says Chrissy needs to take 12 more specific courses for a bachelor's degree, including 4 in math, 3 in physics, 3 in computer science, and 2 in business. That's all 12 classes. It says if 5 courses are randomly chosen from these 12, so we're just picking 5 just at random for next semester's program, how many of the possible selections would include at least 2 math courses? Now with that at least, you could work with the complement. But let's think about, first of all, what does that mean? At least 2 math courses means 2 math courses or 3 math courses or 4 math courses or 5 math courses. Does it really mean that? Look, if you go back and look, notice there are only 4 courses in math. So 4 is the most you could possibly random select because there's only 4 available to select from. So we could just use our OR calculations to calculate these 3 separately. Or the other possibility is you could calculate how many options have 0 math courses and how many options have 1 math course, and subtract that from the total options. So really it's about the same amount of work because this is 3 separate calculations that we have here, 2 math courses or 3 math courses or 4, and then we add. Or we find the total number of math courses and subtract 0 and subtract 1. So how about we just focus straight away on these 3, okay? Now 2 math courses. Now what does that mean we're really doing? Okay, so first of all, things we need to ask ourselves. Is replacement a possibility or is this without replacement? And next, does order matter or does order not matter? Okay, we don't even have to address the order situation unless we address the replacement. So if you pick a class, do you put the class back in the pile to pick again? Well, no, not at all, right? Once you pick a class, you've got the class. So this is without replacement. What that means is, so replacement, no. Anytime it's without replacement, then you can use a combination or a permutation. Now, does order matter? No, because if we select 5 classes, it doesn't matter if math is the first class selected or physics is the first class selected, right? Because when you take classes, that's just not an issue as far as just picking 5 classes to take. So what that means is if you do not have replacement and order does not matter, you're dealing with a combination. Now let's think about what we've got going on here. Notice how we're talking about math classes only. It actually does not matter that there are 3 physics, 3 computer science, and 2 business. We just need to know about math classes, which there are 4 of them. So I'm going to say there's 4 math classes. How many other classes are there? 8, right? 12 total, 4 of them math, 8 of them are the other classes. Now, if we are going to figure out a combination where we pick 2 math classes, what does that really mean? Well, we have a combination of, let's pick the math classes first. There are only 4 classes, so we're going to do 4, choose 2, but we're not finished because we have to pick more classes. So it's 2 math and 3 other. Okay, I want you to think about that every time. When we say 2 math, that really means 2 math and 3 other. When we say 3 math, that means 3 math and 2 other, right? And when we say 4 math, that's 4 math and 1 other, because we still have to pick all 5 courses. So we have 4 math classes, we're picking 2 of them, times, we got to pick the 3 other ones too. So that's going to be a combination again of, how many non-math classes do we have? 8, and we're picking 3 of them. Now notice we have an or right here, so we're going to add that to. This time we're picking 3 math classes, so I'm going to go back to green for math. Now how many math classes do we have to pick from? 4. Okay, how many are we picking? 3 of them. Now in red, let's pick the other classes. Okay, so for 3 math and 2 other, we have another combination, because the order doesn't matter, 8. Choose 2 of them this time. And then there's another or, so I have another plus right here. And then again, 4 maths this time. So I go back and I have a combination of 4 classes, and we're picking all 4 of them. Really, there's only one way to do that, right? But we'll get that calculation in a minute. And then red, a combination of 8 classes, and we're just going to pick 1. So we have a lot of calculation to do. So I'm going to come underneath and do these calculations in the same color again. So a combination of 4 choose 2 is 4 factorial divided by 2 factorial. And then this is 4 minus 2 factorial in parentheses times, in red, that's going to be 8 factorial over 3 factorial, and in parentheses 8 minus 3 factorial. And then a big plus in between. And back to green, I have 4 factorial over 3 factorial, and then 4 minus 3 factorial. And then the other classes is 8 factorial over 2 factorial times 8 minus 2 factorial. Plus, at the end here, more math classes. I got 4 factorial over 4 factorial times 4 minus 4 factorial. And then in red, the non-math classes is 8 factorial over 1 factorial times 8 minus 1 factorial. A lot of calculation to do. You may even want to find that button in your calculator now of how to calculate combinations. But real quick, trying not to write real big, 4 factorial over 2 factorial times 2 factorial. Listen, that's 4 times 3. The 2 factorials cancel on top, and then 2 times 1. Times, in red, right here, that's going to be 8 factorial over 3 factorial. 8 minus 3 is 5 factorial. That's going to be 8 times 7 times 6. The 5 factorials cancel, over 3 times 2 times 1. Plus, lots of simplifying here. Again, you could do this on your calculator as well. This is 4 factorial over 3 factorial. 4 minus 3 is 1 factorial. If I write the top one down and cancel that with the bottom one, that's just going to give me the number 4, and that's it. Times, next to it is 8 factorial over 2 factorial. 8 minus 2 is 6 factorial. So that's going to give me 8 times 7 in the numerator, because the 6 factorials cancel, over 2 times 1 in the denominator. So again, that ended up canceling, just like over here, that ended up canceling with the 5 factorial on top. Okay, let's keep going. Plus, okay, in green, one more math calculation to do here. So we have 4 factorial over 4 factorial. 4 minus 4 is 0 factorial. Now all that cancels. That's just 1 times. And then in red, we have 8 factorial over 1 factorial. 8 minus 1 is 7 factorial. I write the top one down to match the bottom. So the 7 factorials cancel. That just gives me 8 over 1, which is 8. Now let's crunch these numbers. I'm going to move to the left of the page over here. I'm going to erase my comments about replacement and order not mattering to wrap up these calculations, and I'm going to stick to one color, which is going to be black. So 4 times 3 is 12, divided by 2, that's 6, times, right here, this 3 times 2 cancels with that 6, 56, plus, of course we know that's 4, right here, this 2 goes into 8 4 times, and 4 times 7 is 28. And then for the last calculations, that's a plus right here, and 1 times 8 is 8. And in my calculator, I'm just going to type in 6 times 56 plus 4 times 28, and then plus 8, and tell you what I get. So there's your final answer. Notice I went ahead and calculated 6 times 56 is 336, 4 times 28 is 112, plus 8, and then I added 336 plus 112 plus 8 to get a final answer of 456 possibilities for Chrissy to select 5 classes from the 12 that she has to take, where she has at least 2 math courses. All right, so our example in, how many 3-digit numbers are odd or multiples of 5? So notice again the or. So that's telling us to calculate the number of odd 3-digit numbers, okay, plus the number of multiples of 5 3-digit numbers, but we got to subtract out any intersection. So subtract out that are odd and multiples of 5, right? Because there could possibly be numbers that are both odd and multiples of 5. So we'll talk about it as we go through, but one thing at a time. First of all, let's calculate how many odd 3-digit numbers there are, right? Now, does it say anything about reusing or not reusing the numbers? You know, when you build a 3-digit number, you've got 3 tasks, right? It doesn't say anything about we can't reuse the digits. You know what that means? If you can reuse, if you say yes to reuse, that means no permutation or combination is allowed. We simply just have to draw our dashes and do our task, right? So let's just build some odd 3-digit numbers. And I mean counting numbers, and I probably should have made that clear, but we're going to assume this is counting numbers. When I go back and present this PowerPoint presentation, I will make sure I say counting numbers. Okay, so when I say counting numbers, that means that first digit cannot be 0, right? I have a choice of 1, 2, 3, 4, 5, 6, 7, 8, and 9. Those are the only numbers I can use. That's 9 numbers. Okay? Now my second number, I have a choice of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 10 numbers I can use. Now notice I'm not reusing. I am reusing. I apologize. I am reusing, which means I don't need to throw a number out. Okay? I have full use of all 9 here, full use of all 10 here. Now my last number, if it's going to be odd, I can only have a 1, a 3, a 5, a 7, or a 9 right there. Am I right? That's it. A 1, 3, 5, 7, or 9. So I only have 5 choices there. We'll calculate that in just a minute. Matter of fact, let's just do it now. Okay, so I'm going to erase what I have below here. But again, this is all the 9 numbers I had to choose from here, the 10 numbers I had to choose from here, and the 5 numbers I had to choose from there. Again, I'm allowed to reuse numbers, so I don't have to remove one for the choice I made before. So 9 times 10 times 5, which 9 times 10, of course, is 90. And 90 times 5 gives me 450. So there are 450 possible odd 3-digit numbers. So that's 450. And then plus. Now it's talking about 3-digit numbers that are multiples of 5. So space, space, space. I'm building my 3-digit numbers again. If you'll recall, I cannot reuse digits, so I can't use a combination or a permutation. So there are 9 ways to pick the first number. Why? Because I have a choice of 1 through 9 for that number. But now, In my second number, I have 10 options because I have a choice of 0 through 9. And I don't have to throw away any of these options because I used it here. So, 2, 2, whatever we pick here is an option. I can reuse numbers. And then multiples of 5. Now, what makes a number a multiple of 5? Well, how about if it ends in a 0 or a 5? So I have 2 options for that number right there, just a 0 or a 5. Now, when I multiply this together, I get 9 times 10, which is 90, times 2 is 180. So I have 180 options for 3-digit numbers that are multiples of 5. But now here's the deal. We've got to subtract out the intersection. There's probably numbers that I'm counting here and here, right? Are there numbers that are both odd and multiples of 5? Well, sure there are. How do we build them? Okay, well, it's a 3-digit number. So the first digit can be anything 1 through 9, 2 all the way through 9. So there are 9 possibilities. The second number can be 0 through 9, so 10 possibilities. Now, an odd and multiple of 5, y'all. Multiple of 5 has to end in a 0 or a 5. But if it ends in a 0, it's an even number. If it ends in a 5, it's an odd number. So if this number ends in a 5, then it is both things. It is odd and a multiple of 5. So there's only one way to pick a 5. Just pick a 5 and that's it. So 9 times 10 times 1, there are 90 numbers that are both odd and multiple of 5 that are 3-digit. So we're going to subtract out those 90 that we counted in here and we counted in here. So to get this final answer, I do 450 plus 180 minus 90. And when I run that through at my calculator, I get 540 options. So 450 plus 180 subtract 90 is 540 possibilities of 3-digit numbers that are either odd or multiples of 5. And this is our last problem, example O. How many subsets of a 20-element set have more than 3 elements? So what is that really saying? First of all, we have a 20-element set. Okay, now we can calculate subsets of a 20-element set in just a minute. If you'll remember from the beginning of the video, we talked about how to do that in part 1. But how many subsets of a 20-element set have more than 3 elements? So what does that really mean? That means 3 elements, or 4 elements, or 5 elements, or 6 elements, or 7 elements, or 8 elements, or stop me when you got it, right? All the way to 20 elements. Do we really want to do all of those separate calculations? And that would be a separate calculation every single time. So how about we come up with a plan that instead of calculating how many subsets of the 20-element set have 3 or 4 or 5 or 6 or 7 or 8 all the way to 20 and add all those values together, why don't we do the complement? So if we could figure out how many subsets, first of all, are in a 20-element set. So first we're going to find the number of subsets of a 20-element set and subtract out. Now what are we going to subtract out? Well, what is the complement of more than 3 elements? And by the way, did I include 3 a minute ago? It said more than 3 elements, so I shouldn't have included 3 when I wrote that down. Seems like I did. So let's pretend I didn't. More than 3 would be 4, 5, 6, 7, 8, 9, 10, right? All right, so not more than 3. Let me write it that way first. So the number of not more than 3. Another way to write that, again, is the number of, I'm just going to put subsets here, minus, here's where the brackets is where I need that. Not more than 3 means the number of 0 plus the number of 1 element plus the number of 2 elements, right? plus the number of 3 elements. Now we've got some calculations to do. First of all, how many subsets are there of a 20 element set? Well, to figure out the number of subsets, you just do 2 raised to the number of elements. So 2 to the 20th power, which is pretty big. Okay, we'll calculate it in a minute. Minus, now here's where it gets interesting. When you're talking about subsets, does order matter? So if you have a subset AB, is that the same subset as the subset BA? And it is. So order does not matter. So that means we're dealing with a combination. So to do this first one right here, the number of 0 elements, you would have a combination of 20 choose 0, right? But listen, what's a set with 0 elements? That's just the empty set. How many empty sets do you have? Look, that's just 1. There's no need to do a calculation for that one. But the number of 1 element, now if you have 20 elements, how many subsets have only 1 element in it? You could calculate it if you want to, but it's 20, right? Plus, so we're going to save time by not doing calculations that we don't need to do. So again, this is the empty set. There's only 1 of those. This is only 1 element, and if you write each of those 20 elements down, that's 20 subsets. So that's 20. But now, how about 2 elements? There's a little bit of work involved there. It's a combination of 20 choose 2, right? You have 20 elements to choose from. You want to pick 2 at a time. We'll calculate how many that is in just a minute. Plus, how about this guy right here? That's going to be 20 choose 3. Am I right? Now we're only allowed to use this rule when you say or and add all them together if you subtract out the intersection. But there are no common subsets in here because the empty set doesn't have anything common with 1 element sets, doesn't have anything in common with 2 element subsets, doesn't have anything, you see what I mean, 3 element subsets. There won't be any subsets that are in these multiple groups. So the good news is we just add these together. So again, we'll do 2 to the 20th in a minute. Minus, of course, this is 1 plus 20. Now let's do this combination of 20 choose 2. So it's going to be 20 factorial over 2 factorial times 20 minus 2 factorial, plus, how about 20 choose 3? That's 20 factorial over 3 factorial and 20 minus 3 factorial. So I've got 2 to the 20th, again, big number, minus 1 plus 20, yes, that's 21. We'll write it in a minute. But this 20 factorial, look, that's 18 factorial, right? So that means I write the top one down, 20 times 19. And then the 18 cancels. This 18 cancels with the 18 that's out here. And then 2 factorial is 2 times 1. Plus, now this is 20 factorial. This is 17 factorial. So that's going to be 20 times 19 times 18. Again, this 17 factorial cancels with the one on top. Divided by 3 times 2 times 1. That comes from that 3 factorial. Alright, now I'm going to write in black. 2 to the 20th equals 1,048,576 minus everything that's in those brackets. So that's 1 plus 20. Now look, this 2 goes into this 20 10 times 19. So this is 21 plus 10 times 19 is 190. Plus, and then, hey, this 2 goes into 20. That's 10 times 19. 3 goes into 18 6 times. 10 times 19 times 6. Or just type it all in your calculator. 10 times 19 times 6 gives me 1,140. So I've got 1,048,000. This should be a comma. 576 minus 21 plus 190 minus 1,140. Whew, what a mess. Okay, so I added the 21 plus the 190 plus the 1,140. You'll see it got 1,351. So I took my 2 to the 20th, which again is 1,048,576, minus 1,351. I wrote it at the top of the page, top right up here. Final answer, 1,048,576. 47,226. How do you like that big old problem? That wraps up this section. We talked a lot about not and the complement by subtracting that out from the original amount of sets or options or possibilities that you're dealing with on the big picture there. And then we talked about OR, which means you add each situation together, but you always have to subtract out what's in common. I hope this helps you out. Please, please, please let me know if you need any clarification or you have any questions about what we've done or other homework problems. I hope you have a great day.